Think about the last dream you remember. Really think about it. Now ask yourself, how much of it is actually still there? Because right now, as you try to recall it, your brain is actively working against you. The same system that stores your memories is simultaneously trying to erase the dream you're attempting to retrieve. You are in a race against your own brain, and your brain almost always wins. Every single night you spend approximately 2 hours dreaming. That's 730 hours of experience every year. A full month of your life, every year, spent in a world your brain constructs entirely from scratch. Characters appear. Places that don't exist feel completely real. Emotions hit you with full force. Terror, joy, grief, love, and none of it is happening. Your brain is generating all of it. And then, within 10 minutes of waking, 90% of it is gone. Not faded, not blurry around the edges, gone, as if it never happened. Scientists have known about this for over a century. Sigmund Freud wrote about dream forgetting in 1900. But his explanation that the mind suppresses dreams because they contain uncomfortable truths turned out to be wrong. The real reason is stranger and far more mechanical than anyone expected. To understand why dreams disappear so fast, you first need to understand what your brain is actually doing while you sleep. Sleep happens in cycles of roughly 90 minutes. Each cycle moves through different stages: light sleep, deep sleep, and REM. REM stands for rapid eye movement. It's named for exactly what it sounds like. During REM sleep, your eyes move rapidly behind your closed lids, as if watching something. Because you are. This is where almost all dreaming happens. And during REM, your brain looks almost identical on a scan to a brain that is fully awake. Your visual cortex is firing. Your emotional centers are running at full power. Your motor cortex is active, which is why in dreams you can run, fight, and fly. The main difference between a dreaming brain and a waking brain is not activity level. It's chemistry, and that chemistry is everything. Here's the piece that changes how you think about this. While you are in REM sleep, your brain dramatically reduces production of two key neurotransmitters, norepinephrine and serotonin. These aren't minor chemicals. Norepinephrine in particular is one of the primary neurochemicals responsible for memory consolidation, the process of taking an experience and converting it into a long-term memory. Without norepinephrine, experiences don't stick. They can't. The chemical that builds the bridge between experience and memory is almost entirely absent during the period when your most vivid experiences are happening. Your brain is running a full waking simulation with the memory recording system switched off. Think about what that actually means. Every dream you have ever had, every impossible landscape, every person you've spoken to in a dream, every emotion that felt completely real was experienced by a version of you that had no ability to remember it. The dreaming self cannot record what it lives through. It is having experiences it is constitutionally incapable of keeping. But here's where it gets stranger. Because the norepinephrine explanation accounts for why dreams don't consolidate during sleep, it doesn't fully explain why they vanish so rapidly after you wake up. For that, you need to understand something called memory interference. When you wake up and start experiencing the waking world, light, sound, the feeling of your body in bed, the notification on your phone, those new incoming experiences begin competing with whatever dream traces are still present in your short-term memory. And they win, every time. Your brain has a limited buffer for holding unprocessed experience. Dreams occupy that buffer during sleep. The moment waking experience starts pouring in, it begins displacing the dream content. The dream isn't being erased exactly, it's being crowded out, pushed to the margins, and once it slips below a certain threshold of accessibility, it's gone for good. This is why the first 30 seconds after waking are so critical. Most people spend those 30 seconds immediately reaching for their phone or letting their mind jump to the day ahead. By the time you get to the bathroom, the dream is already more than half gone. There's a reason dream journals work. Writing a dream down immediately after waking isn't just a memory trick. It's a race against interference. You are forcing the fragile dream trace into long-term memory through language and repetition before the waking world can crowd it out entirely. But here's what nobody talks about. There's a third factor, and it might be the most important one. In 2011, researchers studying the neuroscience of sleep made a discovery that reframed the entire conversation. They found that a specific receptor in the brain, the acetylcholine receptor, plays a crucial role in whether dreams are remembered at all. During REM sleep, acetylcholine levels are extremely high. This is part of what drives the vivid, hallucinatory quality of dreams. But acetylcholine also actively suppresses the hippocampus, the brain region responsible for converting short-term experiences into long-term memories. So during REM sleep, the chemical that makes dreams so vivid is simultaneously suppressing the very system that would allow you to remember them. Vividness and memory are chemically linked in opposition. The more intensely real real a dream feels while you are having it, the less likely you are to remember it afterward. The brain is running the experience at full intensity with the recording system chemically blocked. It is, in the most literal neurological sense, a system designed to produce experiences that cannot be kept. Which raises the obvious question: why would evolution build this? What possible advantage does it serve to spend 2 hours every night generating an incredibly detailed simulation of experience and then systematically erase it? And here's where scientists split into two camps. The first camp argues that dream forgetting is not a design feature. It's a side effect. The norepinephrine shutdown, the acetylcholine surge, these serve other purposes. The memory erasure is just collateral damage from processes that evolved for different reasons. On this view, we don't forget dreams because forgetting is useful. We forget them because the system that makes dreaming possible happens to also make remembering impossible. The second camp argues something more unsettling, that the forgetting might be the point. That if we remembered every dream with the same fidelity we remember waking experiences, we would struggle to distinguish between things that actually happened and things our sleeping brain invented. The border between memory and dream would dissolve. We would wake up each morning with a full night's worth of false memories competing with our real ones for the title of reality. On this view, dream forgetting is not a bug. It is a firewall, a mechanism that keeps the dreaming world and the waking world from bleeding into each other. The erasure protects the integrity of your memory. It keeps the simulation from contaminating the record. And there is evidence for this. People who suffer from certain neurological conditions that disrupt normal REM sleep chemistry sometimes report exactly this: an inability to distinguish vivid dreams from real memories. They wake up convinced that events from their dreams actually happened. They argue with family members about conversations that never took place. The firewall is gone, and without it, reality itself becomes unstable. So your brain isn't failing when it erases your dreams. It is, in a very precise and deliberate way, protecting you. Every morning when you wake up and reach for a dream that is already slipping away, the image is going first, then the story, then the emotion, until all that remains is the faint sense that something happened. Your brain is doing exactly what it was built to do. The dreaming self lives fully. It feels everything. It experiences 2 hours of complete reality every single night, and then it hands you back to the waking world with the slate wiped clean so that you can tell the difference between what you lived and what you dreamed. You are in a race against your own brain every morning, and your brain almost always wins. But now you know why it's running.